Every day, millions of people worldwide consume whey protein as part of their diet. It is produced from cow's milk and undergoes several processes in factories to become a high-quality protein powder. But how are more than 10,000 containers of whey protein produced? Every day, from dairy farms to the production plant, we will unveil the secrets behind the manufacturing of one of the most sought-after supplements in the industry. Whey protein comes from cow's milk, specifically from the liquid parts separated during cheese production. For thousands of years, this liquid, known as whey, was considered an unwanted byproduct of cheese and dairy production. It resulted from the milk coagulation process used to make cheese and other dairy products. Whey was highly contaminating to the environment, and its disposal could have negative effects on water and soil quality. Over time, as technology and nutritional understanding advanced, the nutritional value of whey protein and other whey components was recognized. This led to the development of more efficient and sustainable methods to process whey and turn it into valuable products like protein. The process begins on dairy farms, where cows are specifically raised and cared for to produce high-quality milk. Happy and healthy cows are believed to produce high-quality milk, which is the first step in a high-quality protein supplement. On average, a dairy cow can produce around 30 liters of milk per day. Cow's milk contains 3% protein, with whey protein accounting for 19% of that. Cows are milked twice a day, usually by automated milking machines. During milking, milk is extracted from the cow's udders. Milk is rich in nutrients, including proteins, fats, carbohydrates, and minerals. Freshly milked milk is temporarily stored in refrigerated storage tanks to keep it fresh and free from contaminants. These tanks are designed to maintain the milk at cold temperatures to prevent bacterial growth and ensure its quality. The milk is transported from dairy farms to the cheese processing factory. Every day, fresh milk is transported directly to one of the local cheese factories. Here, it is separated into curd and whey, usually using refrigerated transport to maintain the milk at the appropriate temperature during the journey to the factory. The milk undergoes a quality verification process to ensure it meets the required standards before continuing with the manufacturing process. The freshly arrived milk is stored in refrigerated storage tanks until it is ready for processing. Before pasteurization, it is essential to check the quality and freshness of the milk to ensure it complies with food safety standards. The milk is pumped from the storage tanks through a piping system to a heater. The milk is typically heated to around 60 degrees Celsius for approximately 30 minutes. This heating process aims to eliminate and deactivate any harmful bacteria present in the milk, increasing its safety for consumption. After the heating phase, the pasteurized milk undergoes rapid cooling to reduce its temperature to 4 degrees Celsius. Rapid cooling stops the heating process and prevents the milk from continuing to cook, which could negatively affect its quality and flavor. Throughout the pasteurization process, the milk's temperature is carefully monitored and controlled to ensure it stays within specified ranges. After pasteurization, the milk is transported to a specific processing unit designed to separate its components. The pasteurized milk is introduced into a large container and undergoes a mechanical separation process. Following pasteurization, a coagulant is added to the milk, resulting in the formation of a solid mass known as curd. During this process, the remaining liquid, known as whey, contains concentrated proteins and other soluble components separated from the curd. In this cheese factory, curd is used to make fresh cheeses, while the remaining whey is directed to a second line of business. During the separation process, a physical method such as filtration is used to separate the curd from the whey. The resulting liquid fraction is whey, which is rich in whey protein. This phase of the process is crucial for obtaining the desired protein component, which forms the basis of whey protein. The liquid whey fraction may still contain small amounts of unwanted fat and minerals. In some cases, an additional purification step is performed to remove these components and obtain a cleaner and more concentrated whey fraction. In some processing facilities, microfiltration and cross-flow filtration are used to further refine the whey protein fraction. These methods allow the removal of impurities and the concentration of whey proteins, resulting in a pure whey protein final product. This natural, low-temperature process separates protein from fats and lactose, resulting in a finished product that is extremely rich in protein and retains essential nutrients. The result of this step is a highly concentrated liquid whey fraction with minimal fat, carbohydrates, and other unwanted components. Once whey protein is filtered, it undergoes an evaporation process. The whey is introduced into industrial evaporators designed to remove excess water from the liquid fraction. The evaporation process is conducted at a controlled temperature to avoid damaging the proteins present in the whey. The temperature may vary but is typically kept relatively low to preserve protein quality. Evaporation is a controlled process that gradually removes water from the liquid whey fraction. During this process, water evaporates and turns into vapor, while proteins and other solids remain in a concentrated form. After much of the water has been removed, the concentrated liquid fraction undergoes a drying process. Drying involves the introduction of hot and cold air into the concentrated liquid stream. Hot air helps further evaporate water, while cold air assists in cooling the product. This drying process ensures that the final product is in powder form with minimal residual moisture. Subsequently, the resulting powder is sieved to remove any larger particles and ensure size uniformity. After this stage, the whey powder is introduced into a mixer to remove any remaining moisture and achieve a homogeneous mixture. It is then packaged in bags for sale to wholesalers. These bags are sent to the protein factory, the world's largest protein factory, which operates 24 hours a day, 7 days a week, handling hundreds of tons of whey protein and producing thousands of products in the company's extensive food supplement warehouse. Thousands of bags of whey protein powder arrive daily. The materials are then transported from here to the weighing room, where all raw materials are weighed. All raw materials pass through a fine sieve, typically with a 2mm opening. This ensures that all ingredients are carefully broken down and easy to mix. Whey protein powder is transported to the mixing area, where different flavors are added to give each product its unique and delicious taste. Subsequently, the powdered protein is mixed for a few minutes in these rotating drums. An operator places empty containers on the conveyor belt to start the filling process. In this stage, an automated filling machine is used to fill the containers with the appropriate amount of whey protein powder. In this process, a worker uses a vacuum hose to transfer the protein from the bags to the packaging machine. Filling is done precisely to ensure that each container contains the specific amount of protein. After filling, each container undergoes a weighing process to verify that it contains the correct amount of whey protein powder. The containers advance on the conveyor belt to the next stage, where another worker places a measuring spoon in each container and properly seals the corresponding lid. A visual quality check is performed to ensure that the product looks correct and free from visible contaminants. Each container is labeled with important information such as the product name, nutritional information, usage instructions, expiration date, and batch number. Once the labeling process is completed, an employee inserts a plastic ring into the lid of each container. The containers are then directed to a heat sealing machine that seals the plastic rings with heat, ensuring a tight and precise closure. Filled and verified containers are placed in boxes for ease of transport and distribution. Give the video a like if you enjoyed it and share it with someone else who might be interested. Also, subscribe to this channel and enable notifications to keep learning.